Okay, so this video is just a quick little video to remind you guys how to do transformations. So I'm going to start with just f of x equals x squared. If I wanted to move this, let's say, up 3 units, I could represent this by adding 3 to the f of x, or I could add 3 to actually x squared. Both of these would be ways that you could represent up 3 for this parabola. Okay, what if you wanted to move down? Let's say we wanted to move down 5. Well, then we would just subtract f of x minus 5, or I could write it as x squared minus 5. Okay, the shifts left and right, a little bit different, not too much. If we wanted to move right, we'll say 2. We would just have to put it inside the parentheses. Now, you'd think it would be plus 2 because it's right 2, but it's actually opposite of what you'd think. When I'm writing it in terms of x squared, I would still need parentheses, x minus 2, and then the squared part. If I wanted to move left, we'll just say 1. That would be f of, and you guessed it, x plus 1. Or we could do x plus 1 and then squared. Okay, so we're still going to transform f of x equals x squared, but this time we're going to talk about stretches and compressions. So let's say I wanted a vertical stretch. I wanted to make it really tall, vertical stretch. I would need to multiply f of x by something like 2, a number larger than 1, or this would be represented as 2x squared. If I wanted to vertically compress it, making it really short, I would just use the inverse. So I could use 1/2 f of x. This would change all the y values to be half of what they previously were. If I wanted to do horizontal changes, I would need to, it's going to be opposite of what you'd think again. So I need to move the number to the inside, so it's going to be f of, but it's not going to be 2 for a stretch, it's going to be 1/2 for a stretch. And then in parentheses it would look like 1/2 x squared. A horizontal compression would be, again, opposite of what you'd think. Compression, you'd think small, but that would be multiplying all the x's by 2. Horizontal changes are always just opposite of what you'd think. Okay, if you wanted to reflect this parabola, and this time we would reflect it across the x-axis. This could also be called a vertical reflection because the top goes to the bottom and the bottom goes to the top. The way we would write this is negative f of x, or I could write it as negative x squared. Now, it doesn't really make sense to do this with our parabola, but if you wanted to reflect across the y-axis, and the reason I say it doesn't make sense is because think about it. A parabola looks like this. If I reflect it across the y-axis, it looks the exact same. This would be what I call a horizontal reflection, where the left goes right and the right goes left. This would be f of negative x, or negative x squared, and I can see algebraically here why this is the exact same thing as x squared, but it gives you an idea of what you need to do. Okay, for our last transformation, which I'm going to call the absolute value transformation, I'm not going to use just the standard parabola. I'm going to use an already shifted parabola. Absolute value would be written as absolute value of f of x, or you could say absolute value of y. Remember, absolute value takes whether you have a positive or a negative, turns it into positive. So everywhere we have a positive y value, which would be the up piece right here, remember this is our y-axis, that stays the same. What goes away, though, is where the y's are negative. They end up getting reflected up. So once again, where the y's were positive, we kept them the same. It should be up here. It stayed the same. And where the y's were negative, got reflected up. And this right here is your final graph for absolute value of f of x, or absolute value of y.